Hey there everyone, welcome to the series Automate the Boring Stuff in Ansys Mechanical. In today's video, we will be looking at geometry data model object. You will see I have 6 bodies here, and if I go to space claim, I have 4 bodies outside and 2 bodies. I have grouped it into a component named as comp1. So if you see, I have grouped it here. You can also use share topology, but right now I don't have any faces or any of the feature that is in contact with each other. So I have put it under group. And when you come back to mechanical, you will see these are all the bodies that are aligned, and these 2 bodies are actually grouped under comp1 part and other 2 are outside. So I have also grouped 2 under a folder which is named as folder 1. So we will go through all the childrens of this geometry and see how we can access individual parts present inside the geometry. So first we will access the geometry. Let's see how what is the entry point for geometry. It will be axt API dot data model dot project dot model dot geometry. So if you see, it returns system type of Ansys ACT automation mechanical geometry, and let us store this inside a variable named as geom. And if you do that, if you want to get the type of that, so we have seen in our previous videos, so you can just type geom dot get type. So it will return it's a type mechanical geometry. So let's see how we can access individual properties of this, and after we do that, we will get into the childrens of the geometry, and then we will see what are the actual hierarchy of geometry. Like under geometry there will be an assembly, under assembly there will be part, and then body, then all those either shell or beam, whatever line elements if you have, that will be coming under that. So let's start with geometry properties. So first thing, we will go as per the existing view that you're seeing on this details of geometry. So first will be geom.source. So it returns a string. It will give the uh, path where your 3D model is available, and if you are importing it from space claim, it will show a space claim. If it is design modeler, it will show as design modeler, and you can access by geom.type. If you do that, you will see it returns, it's a get property and it's a string, so it will return space claim. And then next is geom dot length unit. So this is the unit that is the way you have modeled. So I have modeled in meters, so it's showing as mks. If you change it to let's say feet or anything, even then if you do, you will see it's not changing because it's a read-only property, and it does not depend on the unit system you are presently in. It depends on what unit system you have created this geometry. So many of you must have noticed, if you have multi unit geometry in maybe in SolidWorks or some other CAD software, it gets difficult. So only way is you have to convert it into a neutral format and then you can import it here. Next is geom.element control. I have never used it anywhere. Let's go to display style. You will see it returns body color. This is actually useful if you are trying to create any report. For example, you want to color these 6 bodies based on materials. Uh, so if I make it as material, you will see everything is grayed out using structural steel. So let's go to engineering data and create one more material. I will duplicate it and rename it as uh, mat A, and the top one as mat B. And if I refresh the project and go back, let's assign these 2 bodies as mat A and rest everything mat B. If I go to geometry, it's showing same color. The reason is it doesn't have any different Young's modulus, all those stuffs. So let me make it 8000 here, and this one as 40,000. Okay, it's not showing. Maybe there is some issue. But usually when you do that, it will change its color based on what material you have chosen. Ideally, it was showing. I'm not sure why it's not showing. Let's pick up some other material here instead of steel, maybe an aluminum. And if I refresh that, let's say if I change this to aluminum alloy, is it changing? Yeah, it's changing. So I think these two, they are taking a same color. So if you do that, you can see uh, this particular part has sorry, the particular body is having a different color. You can even change the display style. So right now, if I repeat the code, it will show as material. If I go on to uh, the body color, you will see it's a get and set property, and whatever it's returning is E. So E stands for enum, and if I want to change it, I just have to type the enum name. So it's prototype display style type. So you just understand there are two things. One is prototype group and prototype. So prototype group is the entire geometry. It's an internal name of the geometry, and if it is a individual bodies, then it will be prototype, and geometry is prototype group. So it will be dot. You can make it back to body color. So you will see this has changed to body color, and you can also access the length x, y, z inside the bounding box. So it will be geom dot length x. So you will see it's returning a quantity. If I rerun that, you will see it's a get. Uh, yeah, it's a get property, and it's returned a particular class which is of type. I mean, the name of that class is quantity. So this is showing in feet. If you change it to millimeters and rerun that code, you will see it's based on the present unit system. So it's in now. Similarly, you can access length y uh, and z, and let's go to volume. So it will be geom dot volume. It's also a get property uh, of type quantity. So you will see it's a the volume with millimeter. It's basically the millimeter cube. Similarly, mass you can access. And other things, if you want to know how many bodies are present inside this geometry, so it will be geom dot bodies. So there are, as I said, there will be two different things, parts and bodies. So right now it's showing only uh, bodies here. If I select any one body, so this will show how many active bodies are here. If I suppress any one, so you will see active bodies has become 5. You can even check the check individual state of this bodies. So let's unsuppress it. We will suppress it using the command window, and then you can see if there are any solid bodies, surface bodies, line bodies. I mean, these are the options that comes in when you create a new geometry. For example, if I create a new geometry, before I create anything, you have these options to choose, like whether to import solid, line, surface, all these things. And then you will see all these read-only properties. So very rarely you will use this all the properties. The most important thing that we'll use is children's, and then you will access individual parts or bodies. So let's clear this and go to geom.children and see what it returns. So when I do geom.children.count, you will see it's actually returning 6, but it doesn't mean that that 6 is the 6 bodies that you see in this graphics window. So the first thing that it shows is a folder, then a part, again a part, part, and part. So you have 5 part and 1 folder. But if you look here carefully, it's actually, I mean, let's see the main in the original tree, not in the children tree. So if you see this geometry as a parent, you will see you have a folder, then a part, then 2 bodies. So basically it should return you 4, but you are still getting 6. The main reason is the folder that you see is what you have created. It's not actually uh, internal feature. So if I delete this or ungroup it, you will see that the bodies are not deleted. It's just ungrouped. So that's the reason when you group it, let me group it again. So if you group it, you will see these are all also counted when you get the children. So first thing is you get this folder, then it will still go inside this because as I said, the folder is just a feature that you are seeing. It's not an internal feature. So it will go inside this. It will read these two bodies, then it will come out. I mean, not the bodies, the parts. It will read two parts here first, and then it will come here. It will read this part, but it will not go inside this because these are internal children of this parent. It's not a direct children of geometry. It's a children of this component part. And then here one more part and this part. So 1, 2, 3, 4, 5, 6. This 6 you are getting. So if you want to know whether these 6 are actually showing or not, let's iterate over this parts or the children's. For example, for I in geom.children print I dot name. So if you do that, you will see first it return new folder. This is the one. Then comp1. After this, it's showing sys underscore sys underscore sys underscore. So we don't know which sys underscore it is highlighting. So if you want to clear those things, you will see that all these 4 bodies are under one parent, which is sys underscore. That's the reason you are getting everything sys. Uh, so let me just explain it more nicely here. So first thing that you see, let's put it in this way, children, and then again children. Okay. So first thing what you get is a folder. Then you have comp1. Let's finish children first. I mean the folder first. So let me rerun that code and go inside each of the children. So what I will do is I will just create a line here so that you know which children it is entering, and once it does, we will again run a loop for x in I dot children print x dot name, and then print. This is the end. Okay. So if I do that, so let's understand one by one. First is new folder. Now this new folder has two parts. Okay. So this is sys underscore, but we don't know how many bodies are inside this part. And then it will go to comp1. Comp1 has body directly because this behaves as part. So this is part, this is part, and then you get two bodies, which is body E, which is B body, and next is body F, which is also body. So what are the things that are covered from here? We have this, we have body E, body F, we have new folder. You got these two children. So we don't know whether this is body C or this is body C. And next we have is sys underscore body. So next children of is sys underscore, which is again a part, and it has one more children, which is a body. So it is sys underscore body A. This is body, and then again sys underscore, which is a part. Again you have sys underscore body B, which is a body. So all these things are covered. Only thing is not covered is uh, body of these parts, these two. Okay. So to do that, what you need to do that you have to do is you have to go inside this part and then again access the children. So this will be basically body C and this will be body D. So these are bodies. So this is how it works. So the hierarchy of geometry is first is geometry. Under it comes the assembly. Under it is a part, and under that is body. Under body, there will be several minor features like solid, surface, line, all those stuffs will be included here. So this you need to remember. So when you access something inside a group or inside, let's say a part, so you have to make sure that what you are trying to access. So let's let that image be here. I will clear this screen and go one by one. So first thing that we saw is children. So let's access this 0, 1, 0. I mean, the way it was numbered is, so this was 0, this was 1, 2, 3, 4, 5. Yeah, total 6. Correct. So first was, let's access a part, which I will access is fourth one. So you will see it's actually returning a part. And if I go under the children of that again, so it should return one body. So you will see this is a part, this is a body. So let's talk about a part first. So children 4 name is body A, this one, right? So let's name it as body part A. When you go, when you click this object, it's actually a body, it's not a part, but you can still access part properties from here. If you want to if you really want to know how a part properties looks like, so this comp one is the best one. If you go to component one, or let's say the part, you will see here are some properties like bounding box properties, statistics. But when you go to a body, you will get material. This is the additional thing you get inside a body. So we won't talk much on a part. We will just focus on body right now. So body A will be part A dot children of 0. So if you want to know the body A, name of body A, so you will sorry, body A, you will see it's showing body C. Okay, we accessed a different one right now. Maybe um, this was the fourth one. Okay, no problem. We will focus on this body C right now. Children. So let's access body A now. You will see oh, first thing is object ID. So this is the internal object ID of this object. It doesn't mean that, let's clear this out, not required. So this is the body. If you select this body, you will see the eye selection info. So the last video we covered is selection manager. In that we have seen this selection actually shows an ID uh, of 124. But when you go here, this body actually has an internal object ID of 29. So the one which you select here is the data model object. The one you select here is eye selection info that we have already covered in our last video. This is the object ID. If you want to select or get object by ID, there is a command like ext api dot data model dot project dot get. I think it's in data model. Yeah, get object by ID. So you can actually use 29 here. If you do that, so it will return a body. So this way you can access the body object from this tree, not from this selection info. Next is body A dot. Next is coordinate system. So it returns a type of coordinate system. When we will create a coordinate system here, we will assign it to a variable, and then you can come back to here and come back to this body part. I mean body object, and you can change the coordinate system from here. So right now it's just one, the global coordinate system. And then reference temperature, you can also change it. For example, let's go back to environment and check that body a dot reference temperature. So you will see it has become obsolete now. So it should be use reference temperature by body. Use reference. So it's showing false when you make this as by body. I believe that should return true. So this way you can change. And if you want to know the temperature value, it will be body a dot. Just put value. Yeah. So you will see it's returning 22 centigrade. This way you can change. And treatment, I have not. I think this I have not used this treatment before. Let's go to material assignment, which is very important. Body a dot material. So it's written. You should have noticed that it's a get and set property. So it returns a string. So right now it's mat A. If you want to assign mat B to it, so it should be in terms of string and it will be just mat A. So you will see mat A is assigned. If you're trying to assign something else which does not exist, then you will see that error is returned. It will give an exception here. Next is nonlinear effects, true or false. So it will be body a dot nonlinear effects. It's a bool, so you will say true. If you want to make it, if you just want to use the linear metal properties, you can make it false. You will see false. It's not refresh. So if you just want to refresh it, you can do tree dot refresh, and then you will see it has become no. Similarly, thermal strain effects will be body a dot thermal strain effects. It's same as boolean, so it's true or false. All this length x y z, volume and mass of this body, you can access even moment of inertia. You can make it parameterized. um, let's access moment of inertia. Moment of inertia is a read-only property here, but if you're trying to add a remote mass or remote mass, then you can definitely enter those values. Let's see how it looks like. So body a dot moment of inertia, so it's IP1, 2, and 3. And if you do that, you will see that uh, it returns a quantity. So it will be kg millimeter square, and this is the value. We will. I'm going to create a separate video on quantity, how you can assign all these values to. This looks like a string, but it's not a string. It's actually a quantity. In next, we can see get children. So it will be jom dot get children. As we have seen, we have to put what type of children you are trying to get inside this geometry object. Like geometry is the parent right now. So data model object dot, let's start with parts. So I believe it will return 1, 2, 3, 4, 5 part. So if you look that, okay, there is an error. Yeah, you need to give whether it should recursively check inside or not. So right now I have put it false. So you will see that 1, 2, 3, 4, 5 parts are there, and these 5 parts are body C, D, com, A, and B. So if I make it true, there will not be any difference because I have nothing inside right now. I mean, it's the same. If there is a component, again there is one more component. Then if this was false, then this will not go inside while counting. If it is true, then it will count that. Right now I don't have anything like part inside another part, so it's not showing. It doesn't matter right now. And if I run that same code and make it false, and instead of part I will use body. So if I make it false, what are the things that we are expecting right now is 1, 2, 3, 4, because I'm not going inside this. So I'm expecting it to be 4. Let's see how many it returns. It's returning false because no, it should not return false. Let's see what mistake we have done. Right now it's showing 6 bodies, that's fine, but false, it's returning 0. Okay, so there is a reason behind that. these two are inside this new folder, so it's not going inside when you're trying to run get children. These two bodies are also inside this comp1, but this looks like these two bodies, but it's actually inside one more part. So that's the reason it's showing null. Let's do one thing. If I ungroup it, it's still the same, right? So it won't give anything. Yeah. So right now, whatever you're seeing are parts. So all these 5 parts outside are actually part. They are not bodies. That's why it's giving uh, a 0 when you run with false. But if you make it true, then you will get those 6 bodies. Okay. So when you select a body, so if I do body A, which we had assigned before, I cannot access I can access surface area. I think it will be uh, wrong surface area. A body should not return a surface area. It should return a volume. Okay. I think it's for outside surfaces. I'm not sure on that. So you cannot access, for example, this body has 6 faces, right? And almost 4, 4, 8, 9, 12 edges are there. So it's not, you cannot access through this model object, the geometry data model object. So at that time, you need to enter the geo body of this. So there are two things that you need to remember. First is geometry object. Next is geodata, and next is selection info. All right. So geometry object is what is present in this tree. Geodata is contains all the internal features like faces, edges, vertex. All internal bodies, internal features will be present as geodata. And eye selection info is something what you see in this graphics window. So there are various way to move from one stuff to another. For example, from if you have selected something like body A or body C, you have selected, and you want to get the geodata, you can do that. From geodata, if you want to select that body in the graphics window, that also you can do that. Or if you want to go from selection info to geodata, that is also possible. If you want to move from geodata to geometry object, it is also possible. So geodata will be a separate video because we will loop over or we will check all this property. I can just show you how it looks like. So for example, I already have body A. So I will just make it body geo A, and it will be body A dot get geo body. The type of body geo A, you will see it's a geo body wrapper. There are several wrappers inside this geodata. For let's say geodata is the complete umbrella. So first it will have assembly. Under assembly there will be part wrapper. This is actually assembly wrapper. Then it will be part wrapper. Then body wrapper. Under it there will be face wrapper. There will be edge wrapper. And then again vertex wrapper. So these are all present inside one 3D model object. So that is geometry wrapper, and you can access each individual properties. So let's go back to this. Yeah. From here, if I run body geo a dot faces, so you will see it's written something like geo face wrapper. And then if I just round count of it, you will see there are 6 faces. So this is how it works. So you can even access, for example, body faces 0, right? So it was the first phase, and from first phase you can just get ID of it. So it's not object ID, so it's just ID. So you are getting 131. So we know that actually body C was named as um, body A in this console window. So I will just select all these faces, and one of them should be 131, right? So you will see, yeah, you have 131. Let's loop over all the faces and run print uh, print the IDs of it. So it will be for face in body GOA dot faces print face dot ID. So you will see 131, 138, 120, 21, 22, 23, all these are available here, right? So this is how you can loop over this. But remember, what you are selecting here is iSelection info. The properties that you are getting in selection information is geodata. The one which you are selecting here is um, the geometry object. So don't confuse between them. So if you're trying to loop over all the faces, or if you want to see what kind of face it is, yeah, I think I can run that now for the time being. So phase 0 was 131, right? So if you want to get the type of it, so it will be body, I mean that face dot surface type. You will see it's a plane, right? So there are several types of faces. It can be circular. We will have a look on those in our next video when I will create for geodata. So if you select, for example, this face, so it shows here of type plane. So this is what you are getting it here, geosurface plane. There can be cylindrical as well. So for example, if you have a bolt holes, you can loop over all the holes and do whatever stuff you want to make. So I think that's all we had for today. Geodata, we are going to create new video. Selection information is covered in uh, selection manager. Geometry object is also covered in this video. Yeah, I think we can create this point mass and faces. So it will be like geom dot add. Let's see what are the things that you can add. Comment. We have seen distributed mass is this one. You can distribute a mass on a surface. Figure, image are common things. Yeah, there is this one. Add point mass. So let me assign it to PM. PM is equal to geometry dot add point mass. You will see the point mass is added here. You can access PM dot mass. So right now it's 0. If you want to assign it, it should be a quantity. So you can just type quantity and then square brackets and then type in your values. For example, I want 200 kg. No, it should be parenthesis. So you will see 200 kg is assigned here. Similarly, you can even assign mass moment of inertia in x, y, and z direction. So it will be pm dot mass moment of inertia. And if you remember, it's in kg millimeter square. So let's copy that quantity. I will just make it 100 kg millimeter. If you run that, you will see this is updated to 100. Similarly, you can even assign where you want to add this point mass. For example, if you want to change it to some other surface, it will be like remote mass point. That way you can change this. You can even add those faces like as we talked in our last video. If you want to make changes to this surface, you just assign this surface into some iSelection info, and then you can do it here. Because if you run that, these are locations. This doesn't come under geometry. It's telling geometry. So if you write pm.geometry, you won't get anything. So it's actually location. So you will see it's showing 131. So I believe this red surface is 131. So similarly, if you run that, you will see it's not a list with some integer. It's actually iSelection info. It's a get set property of iSelection info location. So if you want to make that, you have to convert this face into iSelection info, then you can assign it here. If you want to do that using a name selection, you can drop down here and choose the name selection here. But that is actually not required because uh, it is coded in such a way that if you are sending a face, it will automatically choose geometry selection. But if you are sending a name selection to its location, which is something under the name selection, this scoping method will automatically change. So you don't have to go to pm dot scoping method is not here. Yeah, right. Scoping method is not here because using location you can find out uh, what type of surface you have chosen. Even if I do dir of point mass, I think you won't get scoping method in rs state suppressed to string. Yeah, it's not there. One more thing I think I didn't cover is the body state. So right now, if you see here, it's yeah, this suppressed. Okay. So if you want to check the suppressed state, if it is true or false, or if you want to change the state of it, so it will be body a dot suppressed. So it's showing false. If you want to make it true or get it suppressed, so you will see it's gone now, and the suppressed has become yes. So based on that, you can change. Yeah, you can even check if this particular body is meshed or not. So this is a hidden feature. You can just type body a dot object state. It won't come with IntelliSense. So O is capital, S is capital. If you do that, you will see it's telling fully defined. But if you mesh it, it will be something else. Let's rerun that. Yeah, it's showing meshed. So this way, when you're writing some large codes, you can check whether this body is meshed or not before you click on solve. You can catch those errors. This way you can work. So I hope you enjoyed this video. If you have any questions, do let me know in the comment section below. Don't forget to subscribe and have a good rest of your day. Thank you.